Ready? Hi everybody, good morning. My name is Helaluddin. I'm a chemical engineer. I'm feeling bad because most of my friends are on for biofuel, but I'm talking something about fossil fuel. So, yeah, but imagine if you always use that biofuel and you have left over all those fossil fuels, especially in the US. They're the second reserve in the world. US has the coal. So what you are going to do with all this coal? But there is an environmental concern. If you burn coal, you're producing more of this carbon dioxide, which is a big issue. And you can't emit all of your carbon dioxide to the atmosphere. So now today I'm going to give you a new idea. Not as new, but it's out there for the last 10 or 15 years. But still there is no industrial or large-scale practice. It's still in laboratory scale. So how many of you know about the term chemical looping combustion? Oh, that's good. OK, so it's my opportunity to tell the rest of the people about what is chemical looping combustion. So what the traditional combustion do, you have a fuel, and you have air. So when you burn, you have carbon dioxide, then your steam, and also excess nitrogen and oxygen in the air. So now you can't emit all those carbon dioxide to the atmosphere. You have to separate this carbon dioxide and steam. So if you cool it down like that 0 degrees Celsius, this will be ice, but it has a freezing point minus 78 degrees Celsius. So it's very hard to separate this carbon dioxide. And also, in this flue gas stream, the carbon dioxide concentration is only 15% or less. So it's very expensive and elaborate process to separate out this carbon dioxide. So now the people are thinking smartly, how can they separate this carbon dioxide without separating this large amount of nitrogen? Because as you know, in the air, 1 mole of air, it has 21% of oxygen and 79% of nitrogen. So you are putting only one and four times more the inert things. So it's really hard to separate out this carbon dioxide. Now, here is the chemical looping combustion, what they do. They use 2 different reactors. So the one they call is air reactor, and the other one they call fuel reactor. And what they do, for simplification, let's assume they use one metal like the copper. So in the air reactor, they use these materials or metal that's called looping material. That's why the other name is called chemical looping combustion. So in the air reactor, you supply the air. This copper become oxidized and give you copper oxide. Now, if you anyhow transport this copper oxide to your fuel reactor, what you will get, this copper oxide will burn and give you carbon dioxide and steam. And when this will reduce, you will get pure copper, which you can transport back to your air reactor. So now you have pure copper. You can again reoxidize with your air and continue the process. Maybe 100 cycle, 200 cycles. Still, there is up to 300 cycle they used it. So now there is no separation technique because from this air reactor, you are getting your nitrogen and oxygen. So you don't need to worry about that. You can leave it to atmosphere. But from this reactor, you are getting pure carbon dioxide and steam, which you can cool it down. You will get your water separate out. if you want carbon dioxide in the gas stream, gas phase, you can go only 0 degrees Celsius. Then you can use your pure carbon dioxide for other purposes, like Coca-Cola use a huge amount of carbon dioxide every day to process those beverages. Or if you want, if you have more carbon dioxide, then you can go that temperature, 70 degrees Celsius. Then you can get the ice, carbon dioxide ice. Then you can dump it to the geological formation underground. So you don't need to worry about that carbon dioxide anymore. Or, so this is the technology that currently not in the market, but still is in the developing stage. And the reason is we have huge amount of coal. And if we want to somehow build up a technology like this to burn this available fossil fuel, we will not waste of them. So we have to anyhow use of them. So this is one of the current technology that we can implement to burn those huge amount of coal around the world. Thank you. Any question?
What sort of scale are you working with in your lab, or how far along is this technology? You said it's not.
Still in the US, there is, in the Connecticut, they built 3 megawatt power plant.
Oh, wow.
Yeah. That's the biggest one still have in practice. But still, they are thinking this is like lab scale practice. Yeah.
Could you use a Fischer-Tropsch reaction for use your carbon dioxide and make biofuels out of it or something else?
No, Fischer-Tropsch is different, like the carbon monoxide and hydrogen. So the syngas. Yeah, we can use that Fischer-Tropsch beforehand. Like we need to gasify the coal. So if you can use that Fischer-Tropsch to make this carbon dioxide and hydrogen, the syngas. Then we can use that in the fuel reactor without giving the solid fuel, which is always hazardous to handle solid fuel. So gaseous fuel is more easy to burn.
What kind of geological formations can you put carbon dioxide in?
Especially this oil and gas recovery system. Now they are using hot carbon dioxide. They're pumping this carbon dioxide to the formation so that the natural gas and other crude oil, they can come out. So that's the main use of carbon dioxide.